Hi students, MCQ number 19. At what temperature the RMS velocity of gas molecules would be double of its value at NTP if the pressure remains constant? Now initial temperature I can take it as what? T1. So T1 is equal to what? Absolute zero. Means absolute scale is 0 degree Celsius. At NTP it is 273 Kelvin. Okay, this is the clue. And at a temperature T2 is equal to T. We have to find out the relationship at what temperature RMS velocity. So V2 is equal to 2 times V1 is given. So at what temperature, that is at T, the RMS velocity would be double of its value. Okay. So I will write the usual expression for the RMS velocity. V is equal to square root of 3RT1 divided by M. So the gas remains the same. Therefore 3R by M is a constant. So V1 is proportional to square root of T1. And V2 is proportional to square root of T2. Therefore, V1 by V2. So, V1 by V2 is equal to square root of T1 by T2. So, this is equal to square root of, we can substitute what? 273 divided by T2 is T. But V1 by V2, see here, V2 is equal to 2 times V1. So V1 by V2. So this is equal to what? 1 by 2. So this is 1 by 2 is equal to square root of 273 divided by T. Now squaring on both sides. So the left hand side will become 1 by 4 and the right hand side will become 273 divided by T. Now cross multiplying, therefore T is equal to 4 into 273. So 4 3s are 12, 29. So this is 1092. Okay. So T is equal to 1092 in Kelvin. But we have to convert this in degree Celsius, or we can also write T is now equal to 1092 minus 273. So that is equal to 819 degree Celsius. So in Celsius I have converted. So the required answer must be what? 890 degree Celsius. So option A must be the correct answer. Therefore option A is the correct answer. I hope you must have understood well. Fine.